Welcome, everyone, to the first of our Keeping Current seminars for the semester at our brand new time of 4 o'clock on Wednesday afternoons. The schedule is filling up, but not quickly, so I'm eager to have more people suggest and present. And today we've got two fantastic talks, and everything is being recorded, which means that if you don't want your face on the recording, you might want to turn it off. If you don't mind your face on the recording, you can just leave it on. The recording might or may not include some faces. And today we'll begin with Ken Calvert talking about one of his favorite subjects, how to ask a question. Go ahead, Ken.
Thank you, Dr. Finkel. If I may, I will share my screen. Let's see, I think I'll do it this way. I find that PowerPoint and Zoom don't always play very well together, but okay, can you see my screen?
Yes.
All right. So
we can see a screen.
You can see a screen. You can't tell if it's mine or not, but it has my name on it. So, so I'm going to start with a story. Many years ago, a long time ago, in a galaxy far, far away, I was teaching a network class, and I gave my students an assignment to implement a simple client-server protocol. I gave them the spec for, and I got an email. I don't know, it was probably late at night or something. I happened to be on and reading email, and the student says that when I call connect after I create my socket, it fails with error E invalid, and I can't figure out why. Now, was this a good question? So we'll come back to that question. The thing is, in this particular case, I was able to immediately give this answer. Your conditional statement is not doing what you think it is doing. And I was able to answer that question, which I'll tell you was not particularly a good question because it really didn't give me enough information to answer the question. But in this case, I had seen this question enough times before, and I knew exactly what was going wrong here, and was able to tell the student that because I had seen that many students, this was before I wrote a supplementary textbook to give students, which they just take the code from that now, but many students write statements like this. So they create a socket and they assign it to a variable and they compare its value to -1, which is what socket returns on error. Okay, and they think incorrectly that assignment has higher precedence than comparison, equality, which it does not. The comparison actually has higher precedence. So the descriptor that's returned by socket is not going to be -1, it's going to be greater than 2. And so this comparison fails and returns 0, which then gets assigned to socket. 0, the descriptor number 0, which is standard input, is not a valid argument to connect to the connect routine. So it fails with E invalid. Now, I was able to answer that because I'd seen that, and I was very proud of myself, obviously, for being able to answer that question. But the student really could have done a better job of asking the question, right? And that's what this is about. So this talk is for anybody who is having a technical question, okay? And it'll certainly make my life easier if students watch this, and maybe other faculty members, other instructors. If students who are trying to debug their code or figure out how to do an assignment, or another example that I had this weekend, trying to figure out why tar is saying, this doesn't look like a tar archive. So that's another recent experience. A student said, emailed me over the weekend and said, I can't unpack the tarball you gave us for this programming project. And I'm getting this, the tar is complaining. I wonder if the file's corrupted. And I said, well, we went on from there, and we'll come back to that. Programmers trying to learn something about maybe a new language, a new platform, a new operating system. I had an experience recently where I upgraded my Mac OS to Big Sur, and it broke something that I do all the time. It turned out to be a bug. I spent probably an hour and a half on the phone with tech support. But if you're trying to learn something new, or you think you may have found a bug, that's always the last thing you should assume, that you have found a bug. You should always assume that you're doing something wrong first. But if you're trying to get help from Stack Exchange or some forum like that, then you want to be able to ask a good question, because people are more likely to help you if you know how to ask a question. And that includes our own technical support people. So if you're emailing help, all of this applies to that. It applies mainly to asynchronous written questions, right? And instructors often say there are no bad questions, and that's true, okay? Please don't hear me saying don't ask a question, rather than if you can't ask a good question, don't ask a question. Definitely ask the question. It's just that you're more likely to get help and get it more quickly if you follow some of these principles. Okay, so the bottom line, I think if there's one overarching principle, I would say that it's empathy. So put yourself in the place of anybody who may try to answer your question, and have some empathy with them and try to help them help you. And that's really what it's all about. If I could probably stop here, and you could go ahead and put that into practice, but I will go on and try to talk for a few more minutes anyway. So you've got some problem. You are going to have to ask for help, or at least you think you are. So the first step is think. Okay, step 0, try to find the answer yourself. And you want to show that you've invested some effort, because why should anybody help you if you won't try to help yourself? Instructors have to try to help you, but they will be more kindly disposed if you make some effort to figure things out yourself. So what does that look like? Well, the first thing you do is check your primary references. RTFM stands for Read, Define, Manual. It may sarcastically stand for something that I can't say here, but that's what we say it stands for. Maybe somebody else has experienced the same problem. So if you go to a forum or something, you may find the same question. So you should definitely search things like Stack Exchange or StackOverflow to see if the same question that you have has been posted somewhere else. And then do some introspection. Have I tried all my options? Have I solved a similar problem? Have I ever seen anything like this? Am I trying to do something that's always worked before but doesn't work now? That's what happened with me when I upgraded my operating system, and something that I used to do all the time stopped working. And so I was pretty sure that it was a problem with the operating system. Most of the time, that's not going to be the case, okay? And I should say that what I was doing was kind of an unusual thing. So, but if you're doing something that's worked in the past, what is different? Are you doing something different? Has something been upgraded? And maybe you need to ask the IT support folks whether something has been upgraded in the meantime or something else changed. And then maybe most importantly, especially for students who are learning something new, figure out exactly where you lose the trail, right? Figure out what you do understand and go step by step and say, okay, here is exactly where I lose my understanding. So the principle there is for somebody to be able to help you, they need to know where you're coming from. They need to understand your situation, and you're probably going to have to tell them. So you need to know where you're coming from. And the best reason of all is that in going through the steps, you may often figure out the answer yourself. And then you don't even have to ask a question. And that's the best thing of all, because you're going to learn something better when you figure it out yourself. Step 2, provide some context. What is it you're trying to do? Describe the problem and include all the relevant context that you can, your code, screenshots, output, whatever seems to be relevant. Now, not all of that's always going to be relevant depending on the kind of thing you're asking about, but I love it when students include code and screenshots. It really helps get to the bottom of things. It's necessary, but it's not sufficient. What platforms? Okay, are you on a Windows machine, a Macintosh? Are you using an M1 Apple processor, an ARM, a Raspberry Pi? What browser, what compiler, what shell? Just let in the question include values for as many variables that are relevant as you know. And if you don't know, just go ahead and include them if you're not sure if they're relevant. Then finally, describe the steps to reproduce the problem, right? You did make sure that it's a repeatable problem. It's not a one-off deal, right? So you should figure out exactly how to repeat the problem. What's the minimum set of things you have to do to repeat the problem? And then describe what you've tried. So construct some hypotheses. Say, well, maybe it's this. I'll try that. And then figure out how to test your hypothesis. And so when you ask your question, include a description of your hypotheses and what the result of your tests. Presumably they didn't pan out, otherwise you wouldn't still be asking the question. But tell what happened when you tested those. And the principle here is you want people to be motivated to help you. And as we said before, people tend to be more willing to help those who've invested the effort to try to help themselves. Step 3, ask a clear and precise question. If you've done everything up till now, this should be straightforward, but it's still important, right? People need to know what it is you're asking. So I went to StackOverflow, and I picked out, this is something that I looked up recently when I was trying to figure something out. And this question is on there. It's 10 years old, but I thought it was a pretty reasonable example of how to ask a question, especially in a forum like this, where you've got a whole bunch of smart people who know what they're doing. They're reading these questions and they're going to try to help you. So the problem is stated up front. I'm attempting to profile some C++ code compiled with G++, including the options, et cetera, et cetera. However, in spite of the fact that the program takes 10 to 15 minutes to run, the time it measures are all zeros. The number of calls appears to be correct, but it has the right number of calls, and then person includes some more context, a screenshot of the output, helpfully colored. And then the platform, notice down at the bottom, says this is being done on Windows 7, so I can't use Shark or Valgrind. And that's anticipating some suggestions and saying, well, I thought of that, but I can't do it. And then the person lists some hypotheses that he or she considered and rejected. So it's not a matter of doing string finds or comparing to some other slow external functions. The program runs correctly. I have no reason to believe the profile data isn't being written correctly. And it actually points to some other suggestions. So this person has clearly done their homework to try to find a solution. And then finally, there's a concise question and a precise question. Is there a reason that is recording 0 seconds being spent in each function? Now, you know, a more concise question would have been, why is it recording 0 seconds? But that's pretty good. We'll take that. So a couple of notes. Sometimes the context can be concisely communicated. So when you're speaking with experts like this, you don't always need a whole lot of context. So here's another example. It's a little bit more concise. I really like this statement of context here. A Python client communicates with a Java server across an unreliable channel, and they must communicate package corruption via CRC32. Now, that may not be meaningful to everybody, but in the forum where this question's being asked, it's probably communicates very clearly what's going on. Then there's a description, a more detailed description of the problem. On Java's end, the value's unsigned, which you can tell by it's returning a long here. But on Python, it's signed. And then finally, there's the question. Is there a way to compute the checksum in Python CRC32 to match that of Java's? In other words, make Python CRC32 unsigned. So that's a great question. The person doesn't say anything that they've tried, but it's very concise and precise. So the principles, again, be respectful. Do your part before asking. I love this quote from Herb Simon: learning results from what the student thinks and does, and only from what the student thinks and does. So when we answer a question, and I'm going to talk in a second about answering questions. When we answer a question like I did in the first example, just giving the answer, maybe we don't always serve our students well. If we just give the answer, if we've heard the question 100 times, maybe we need to help the student think and do some things that will help them learn more. And then be precise. And always, when you're going to send a message like this, read it several times before you send it, whether you're sending it to help or the IT help department or to StackOverflow or to some of your friends and some of your colleagues like I did this weekend. Try to make sure that they're going to understand what you're asking. So what about asking questions? Answering questions. I think the same principles apply. If the question is maybe not good, not so good, then you want to gently lead the questioner to what's needed. So a lot of times I will say, I'm sorry, you just haven't given me enough information for me to help you. Please include some more details. And I'm showing that I'm willing to help, but I just need them to do a little more work and help me a little bit more. If you're taking part in one of these forums, maybe it's a development forum on GitHub or something like that. You want to say, okay, if you see a question and you're thinking about answering it, you should ask yourself, am I the right person to answer this? Do I have the expertise needed? And then maybe wait and see if somebody else answers it a little bit. That's better than taking a wild guess, which generally is not helpful. If the question has sat there for a long time, you might try to elicit some more information or maybe even take a guess. Okay, that's all I got. But I'd love to hear questions from you and suggestions or discussions or arguments, disagreements with anything. We have a few minutes, so.
Yeah, let me ask a question.
Yes, Dr.
It often happens when there is a technical talk. I've heard this in computer science, but I've heard it much more in the humanities. When someone wants to ask a question, the question is not precise and is not said in one sentence, but goes into a long rambling discussion first. So can you say something about oral presentation of questions?
Right. So, yeah, obviously, it's not always possible to ask a concise question. Sometimes, so this is my opinion, right? Your mileage might vary, and I would love to hear what other people say. Sometimes you have to give context. You have to set up the question a little bit. But if that goes on too long, then people start to think, okay, this person just wants to give their own talk. They're not really asking a question. So I think the setup should be as short as possible. Maybe not shorter, but and so that suggests that you really do want to think before you ask the question. Frame it carefully before you ask it.
I have a question, Ken.
That's my 2 cents.
It may not be a question.
Okay, but answers are also. Sorry, go ahead, Dr. Trzynski.
Thank you.
Hello?
Much of what you said would probably apply to something else, to actually writing answers to questions. If we give problems to students and we want them to provide an answer, we would like them to think, we would like them to be concise and precise, we would like them to give context for whatever they write, perhaps illustrate with examples. So I wonder whether this is very nice what you did here, I must say. I enjoyed listening to it, but probably you could very easily translate what you did for asking the right questions into something that would sound writing correct answers, maybe even writing research papers.
Well, and also that makes me think of formulating problems, right? Homework problems. You want to ask it in such a way that you're going to lead the student to do the thinking that they need to do. So that's a great point.
Yes, although I will stress that when you are saying preparing questions for homeworks, you are still asking questions. And yes, I agree, these special questions have to be fair, have to be, in a sense, have to give enough information, have to do it clearly, and so on. But I am thinking that it's also applying, much of that is applying not to asking questions, but to answering questions as well.
Right. So instead of, I think what you're saying is instead of just giving the answer, what you want to do is say, here's how you maybe should have thought about this. Here's how you go through the process.
Mm-hmm.
Yeah. And I will say, with respect to formulating questions, time and time again, student questions make me realize that I didn't provide enough context in the problem that I put on the homework or the assignment that I gave. So you learn from those. Okay, I saw Dr. Seals has his hand up.
Yeah, I do. Thanks, Dr. Calvert, for this great talk. I have used and I have seen used a strategy before where an executive summary is presented and then detail below, kind of like a multi-scale approach to providing what you've suggested is necessary to ask a good question. Have you seen that before, and what do you think about that?
Yeah, I think that one of the examples I gave kind of had that structure, right? And I think that's very thoughtful because whoever's reading it can tell right away whether they might have a chance of answering it or not, right? That's in the context of asking a lot of people. But yeah, I've used that myself when I'm asking questions in some cases. So yeah, executive summary, and then here's all the gory details and the context and the code and everything else.
Thanks.
Dr. Goldsmith.
Thank you. Dr. Goldsmith.
First of all, I want to say what a great presentation, I want to point out that the same thing applies to asking to set up a meeting. That you want to include information such as your own availability.
And the reason for the meeting, right?
That too, yes.
In general, you want to say, yeah, can I meet with you to discuss X? Yeah, thank you. Good point.
Some experience from Bugzilla, which is a website where you can indicate bugs that you found. Often they'll say, not only do we want to know what the problem is, but what did you try? What did you expect to happen? And what did happen? And that's, again, giving more information that will help the answerers. So often enough, I see all the requests sent into help at CS. I answer very few of them because there's a very competent staff. Nonetheless, I do see a range of questions ranging from SSH isn't working to a very detailed question. And a question that says SSH isn't working is very difficult to answer without more context. And so the only thing to do is to say, can I have more context, or I'll phone you, or something like that. And it's a matter of training for people to learn how to properly put enough in the question so that you don't need a lot of back and forth before you can begin to answer it.
Absolutely. That was in fact, the genesis of this talk, I think, was we were talking about we need to do a better job teaching our students about those things.
Yes, although there is something, there is something to be said about simply notifying somebody that something is not working.
That is also true, and I have done that. Are you aware that the NetLab mail server is not working?
All
right, well, thank you for your attention.
Well, thanks a lot, Ken. I appreciate your giving us this talk, and it's something which I think we'll think back at every time we need to ask a question now. So